In previous video, we have seen how we can use the principal component to reduce the dimensions and remove the multicollinearity problem. So these are the scatter plot between different principal components, that is PC1, PC2, PC3 and PC4, and this is the correlation coefficient between the principal components. So this principal component, they are orthogonal to each other by making the linear combination of the normalized variable sepal length, sepal width, petal length and petal width. So we can get rid of with the multicollinearity problem, which occurs when the variables are highly correlated with each other. And we have seen that the petal length and petal width, these two variables, they are highly correlated with each other. If you remember, the correlation coefficient between PC3 and PC, that is petal length and petal width, was 0.97, which was very high amongst all, and that leads to the problem of multicollinearity. Okay, so we'll try to create the biplot. So to create the biplot, I can use the library called DevTools. So run this library, device tools. So we can use this package to create the biplot. We have to ensure that before we create the biplot, we have also installed the library or the package called ggbiplot. So to install this ggbiplot package, we have to install it from the GitHub. I have already installed it on my system, so I'm not going to run this line. So run this package called ggbiplot. So you can ensure this package by installing the library called ggplot2. Run this library. I will run this library. So after running this library ggbiplot, we'll create the biplot using this ggbiplot function. So the first argument that we have given to this function is the principal component. So in PC object, we have all our 4 principal components. We made the observation.scales to 1, then variable.scale to 1. We have groups for the train data set. For the factor variable species, there are 3 different levels for this factor variable species, that is Setosa, versicolor and virginica. Then we want ellipse for all the data instances. Then we also need the circle for the biplot, and then we specify the ellipse probability to be 0.68. So this is the default probability for the ellipse. So this 68% instances will be covered by the ellipse. You can change this value as much as you want till 100%. Okay, let's run this line. Okay, then I will create the scale color for this object G. I will run this line for the direction and position of the biplot. Now we'll print this object G, so which will create the biplot. Okay, so let's zoom this biplot. So this is the biplot. So x-axis represents the PC1 and y-axis it represents the PC2. So PC1, it explains the 73% variability, whereas PC2 it explains about 21% variability. So this ellipse it covers the 68% of instances. So if you change the size of this ellipse, if you change the probability of the ellipse, you can say that I'll increase it to 95%, and let's run this. So zoom this plot. So now you can observe that this ellipse has covered the maximum instances. So now we have increased this probability from 0.68 to 0.95. So 95% of instances will be covered by these ellipses. Now the circle is nothing but the biplot. This circle it has 4 arrows with respect to each normalized variable, that is sepal length, petal length and sepal width. Okay. Now the arrows which are very closer to each other, that means the variables are very similar to each other, and we have seen in the summary of this principal components that the petal width and petal length, they are highly correlated with each other. On the other hand, the sepal length is highly correlated with these two variables, petal width and petal length, and that's why their values are positive. If we talk about the last variable, that is sepal width, which has the negative value that we have observed in the summary of principal component. So the sepal width is far away from these two variables. So the variability between the sepal width and any of this variable is on the lower side. So that means the sepal width is not highly correlated to this any of this variable. Okay. Now the instance which is far away on the right hand side, which has the high value for the principal component 1. If the instance has the high value for the principal component 1, then it means that that instance has high value for these 3 variables, sepal length, petal width and petal length. In the same way, there is one more instance on the which is far away on the left hand side of this biplot, which means that this variable has low value for the principal component 1, which means that it has also low value for the sepal length, petal length and petal width variable. Okay. So this biplot is very important tool to analyze your principal components and their confidence or their contribution to build the machine learning model. I hope you understand. Thank you for watching this video.